Hello my dear students, welcome back to my channel. Today is the 10th lecture of geometrical optics, and in today's class we are going to start with a new topic, and that is prism. We will also complete dispersion in this lecture. So let's begin with the class. First of all, what is a prism? A prism is a homogeneous, solid, transparent and a refractive medium which is bounded by two plane surfaces which are inclined. When two surfaces are parallel to each other, they form a glass slab or a parallel glass slab. When they are inclined, it forms a prism. Right? So this is the 3D view of a prism where two surfaces are inclining at a particular angle. Okay, this angle is called the angle of prism or the refractive angle. So this angle is called the angle of prism or the refracting angle. So this is the angle of prism, and it is also called the refractive or refracting angle. Okay, so let us look at the view from one side. So when you look at the view from one side, the light ray is incidenting on the first surface. So there will be two refractions in a prism because there are two surfaces, right? So this is the incident side, and incident ray is striking the first surface, and the angle of incidence is suppose I, and the angle of refraction here is suppose R, and here the angle of incidence is R dash, and the angle of emergence here is suppose E. Okay, so this is the normal to the first surface and this is the normal to the second surface, right? So I will zoom it so that the angles are pretty clear. See, this angle is I, this angle is R, right? So first surface, you can write the equation 1 into sine I is equal to mu into sine R. So this is the equation from the first surface, and from the second surface you can write the equation. So this is the first surface, and from the second surface you can write the equation mu into sine R dash is equal to mu into sine R dash is equal to 1 into sine E, because this side the refractive index is 1 and 1. We are assuming that the prism is placed in air, right? Now this is the incident ray and this is the emergent ray. You know that the angle between the incident ray and the emergent ray is called the angle of deviation. So what I have done here is I have produced this incident ray forward, and this I have produced this emergent ray backwards. They intersect at this point, then this particular angle will be the angle of deviation, right? Now to find the angle of deviation, first let us look at what else we can find here. See, if this angle is I, then this whole angle is I, right? So I will write this angle is R, then this angle is I minus R. Similarly, if this angle is E, then this whole angle is E. If this angle is E, then this whole angle is E. Okay, because they are vertically opposite angles. And this angle is R dash, then you will write this angle is E minus R dash. Okay, but in this triangle you can clearly see that delta is an exterior angle. So you will write the angle of deviation delta as I minus R plus E minus R dash. So that means delta is equal to I plus E minus R plus R dash. Now let us look at R and R dash. See, there is a very interesting relation here. Listen carefully. If this angle is R and this is a normal, then this whole angle will be how much? This whole angle will be how much? So this whole angle here will be 90 minus R. Similarly, this is a normal and this angle is R dash, then this whole angle will be how much? Because this is total angle 90 degree, right? If this is R dash, then this angle is 90 minus R dash. Now if you look at this triangle carefully, then 90 minus R plus 90 minus R dash plus A has to be equal to 180 degree because it forms a triangle, right? So I'll write the relation here, 90 minus R plus 90 minus R dash plus A has to be equal to 180 degree. That means this cancelled, you will get R plus R dash is equal to A. This is a very important relation, and this you have to remember. The sum of the interior means sum of the angles which are inside the surface, inside the prism, is always constant and is equal to the angle of prism. So the angle of refraction from the first surface and the angle of incidence to the second surface, the sum of these two angles is a constant always for a prism, and that is equal to the angle of prism, and it is also called the refracting angle. Okay, so Here again I will repeat, see the angle, the angle of deviation is I minus r plus e minus r dash. So you will write from here delta is equal to I plus e minus r plus r dash, and that is equal to I plus e minus, see from here r plus r dash is a. So you will get the relation delta is equal to I plus e minus a. So from this conclusion, what you can make is, first thing that you have to remember is the sum of r and r dash is a constant, and that is equal to a, and the second is the angle of deviation is equal to I plus e minus a. So these are the two very important relation, right, that you have to remember. I have taken here r1 and r2, you can take r and r dash also, you can take r1 and r2 also. So I'll draw the diagram again so that it is very clear. See, suppose you have a prism, and the angle of incidence is I, the angle of refraction for the first surface suppose is R1, this time I will take R1, and the angle of incidence on the second surface is R2, and the angle of emergence is E. Then let us see what we will write. I, so this is I, this is R1, this is R2, this is E. You have to remember, again I am repeating, R1 plus R2 is a constant, and that is equal to the angle of prism. And the angle of deviation means what? The angle between this ray and this ray is equal to I plus E minus A. You have to remember these two relations. Okay. Now, if the prism is thin, if the prism is thin, in that case what will you do? If the prism is thin, you will say that angle of this is very small, angle of prism is very small. Okay, so if the angle of prism is very small, definitely r1 and r2 are also small, because the sum of r1 and r2 is a. If a is very small, then r1 and r2 is small, right? Now if r1 and r2 is small, that means what? If r1 and r2 is small, that means I and E also small, I and E also small. If R1 and R2 is small, that means I and E also small, right? So you can write first surface Snell's law is, I have discussed also, 1 into sin I is equal to mu into sin R1. Now because the angle is very small, so sin I can be written as I. So I will write sin I is nearly equal to I, and sin R1 is nearly equal to R1, right? So I will write I is equal to mu R1. Similarly, for the second surface, you will write mu into sine R2, is equal to 1 into sine E, right? But again R2 is very small, E is also very small, so I'll write mu R2 is equal to E. But you also know that the angle of deviation for any prism is I plus E minus A. And this can be written as, see from here, I is mu R1, E is mu R2, but R1 plus R2 is A, so you will get mu A minus A. So from this you will get delta is equal to mu minus 1 into A. This is very important relation. For a thin prism, delta is equal to mu minus 1 into A. Now let us write some important points. First, if the medium on both sides of the thin prism, is suppose mu dash, right? In that case we will write delta is equal to mu relative minus 1 into A, where mu relative is equal to mu of prism divided by mu of medium. Okay, so mu of prism is mu divided by mu dash. So instead of mu we will write mu by mu dash. Second, the angle of prism has to be written in this has to be written in radian. Angle of prism we will write in radians. Okay. And the third thing is, see, the angle of deviation is independent of the angle of incidence. Why? Because, see, delta is equal to mu relative minus 1 into A. Clearly you can see that there is no angle of incidence term here. The angle of deviation is independent of the angle of incidence. This is very important. So here, if you write image formation due to a thin prism, image formation due to a thin prism, this point will be very useful here. Image formation due to a thin prism, you will see that this point is very important, that is the angle of deviation is independent of the angle of incidence. So suppose this is the thin prism and suppose this is the object which is placed here, right? Okay, now let us draw two rays. The first ray is this itself, the first ray is this itself, this ray, and the second ray, suppose let us draw it like this, and the angle of deviation is this. So you know that the angle of deviation in a thin prism is independent of the angle of incidence. So that is why if this angle is delta, this is also delta. So this angle is delta and this angle is also delta, because they are independent of the angle of incidence. So the angle of deviation for this ray, both the rays, the angle of deviation will be same, right? Now they will intersect at exactly above this object, okay? And this is the image, this is the virtual image of this object. If you look from this side, you will not see the object here, but you will see it lifted above, okay? So this distance is the distance between object and image. Let us say it is d, and the object distance suppose is a. Because the prism is thin, we will say the average distance is a, right? Now if this angle is delta, this is also delta because it is vertically opposite angle. So I will write tan delta is nearly equal to delta. Why? Because the angle of prism is very small, so deviation is also very small. So tan delta is nearly equal to delta is equal to, see, tan delta is nearly equal to delta is equal to d by a. So that means the distance between the object and the image is equal to a delta, right? Where delta is mu minus 1 into a. So delta is mu minus 1 into a. Again I will repeat, you have to write the angle in, you have to write this angle in radian, okay? So this is the angle and it has to be written in radian. So this is the distance between object and image formed by a thin prism. This is the distance between object and image, that is d, formed by a thin prism, right? Okay, so this we have so here we have discussed thin prism also together, right? So now let us look at particular important cases. First case here is condition of no emergence. That means no light should emerge from the second surface. If no light is emerging from the second surface, then what is the condition? Okay, the condition is this, but we will derive it. Listen carefully. If I1 is the angle of incidence here, so I will write mu 1 into sine I. Okay, let us take this as I only. So 1 into sine I is equal to mu into sine R1, right? 1 into sine I is equal to mu into sine R1. So this is the first equation from the first surface, right? And you know that R2 is equal to A minus R1, right? And again what you will do here is no light should emerge from this. When will no light emerge from this? When the minimum angle, when R2 minimum is greater than the critical angle here, because here light is traveling from denser to rarer. So when R2 minimum is greater than the critical angle, you will say that no light will emerge. Why? Because if the minimum angle formed here is greater than the critical angle, then all the angles that can be formed here will be greater than the critical angle for whatever be the angle of incidence. Okay, so no light will transmit. Okay, so now you know that R2 is A minus R1. So from this you will say R2 is minimum when R1 is maximum. R2 is minimum when R1 is maximum, right? So that means R2 min is greater than theta c, means A minus R1 max is greater than theta c. Now R1 max, yeah, you can say R1 is maximum when I is maximum. Why? From here, R1 will be maximum when I will be maximum. Okay. But maximum I can be how much? But maximum I can be 90 degree, right? Because I cannot be greater than 90 degrees. So I will write 1 into sine 90 is equal to mu into sine R1. From this I will get sine R1 max is equal to 1 by mu, but you know that the critical angle is also 1 by mu. Sine of critical angle is also 1 by mu. So from this I will write R1 max is equal to the critical angle. So I will say that A minus critical angle has to be greater than the critical angle. That means A is greater than the 2 times the critical angle, right? So from this you will get A by 2 is greater than the critical angle. So from this I will take sine both sides. I will write sine A by 2 is greater than the critical angle or sine of critical angle, but critical angle is 1 by mu. So first relation that I have got is sine A by 2. First I will write this as, see, sine theta c is 1 by mu, right? So I will write sine A by 2 is greater than 1 by mu. That means mu is, if this is greater than 1 by mu, that means mu is greater than 1 by sine A by 2. So this is the condition for, you can remember it like this or like this. This is the condition for no emergence. If the angle of prism is greater than 2 times the critical angle, in that case there will be no transmission to the second medium. Or in terms of refractive index, if mu is greater than 1 upon sine A by 2 or mu is greater than cosec A by 2, where A is the angle of prism, in that case you will say that no light will emerge from the second surface, whatever be the angle of incidence here. One more thing that you should remember is, if the light which is perpendicular to the surface, that is the grazing incidence, if this light is unable to emerge, then no other light can emerge. Again I will repeat, if this light is unable to emerge, then no other light will emerge. This is similar to what we have discussed in a cylinder. But in the cylinder, what we have done here is, this angle was 90 minus R1, but here it becomes A minus R1. That is the only difference. So this we have already discussed in the cylinder, the same situation. Okay. So here now I will again write a conclusion that you have to remember. Listen carefully. There is a conclusion that you should remember. Before the conclusion, what I will do, I will do the second case. See, the first case, again I will repeat, the condition of no emergence is if mu is greater than 1 upon sine A by 2 or A is greater than 2 theta c. Both the conditions are same. What will you say? You will say that there is no emergence, right? Then there is the condition of grazing emergence. That means they are asking you for what angle the light will graze the second surface. Okay, the emergence ray or the emerging ray is grazing the second surface. Okay, see, listen carefully. So let us say that it is for a particular angle I. Okay, so this is I, right? So I will write like this. So this is the answer, but I will derive it. Listen carefully. 1 into sine I is equal to mu into sine R1. This is the first surface. Then the second surface is mu into sine R2 is equal to 1 into sine 90, right? So from this I will get, see, mu into sine R2 is 1 into sine 90. So mu sine R2 is 1 by mu, or you will say R2 is the critical angle. Obviously R2 has to be the critical angle, because at critical angle incidence only the angle of emergence or the angle of refraction becomes 90 degree, right? Now what I will write here is, you know that R1 plus R2 is A, right? So R2 can be written as A minus R1, right? So from this what I will write, sine A minus R1 is equal to 1 by mu. Okay, and from here you get sine I is equal to mu sine R1. Now see, they have asked you the answer in terms of the angle of prism, that is the refracting angle and the refractive index, right? So I have to eliminate R1, right? So what I will do here is, see, so okay, so what I will do, see, I will write here sine I is equal to mu sine R1 and I is equal to sine inverse mu sine R1. But R1 can be written as A minus R2. but R2 is the critical angle. So I will write it like this. See, R1 can be written as A minus R2, but R2 is the critical angle. So I'll write R1 is equal to A minus theta C. So I'll write sine inverse mu sine R1. Again I will write A minus R2, but R2 is equal to the critical angle in this case. So I is equal to sine inverse mu sine A minus theta C. You can remember it in this way also. This is the angle of incidence at which the emergence is grazing, or this is the angle of incidence for grazing emergence. So this is the angle of incidence for grazing emergence. This is the angle of incidence for grazing emergence. Okay, but you can also remember it like this. I will suggest you to remember it like this because this is the easier way to remember. I is equal to sine inverse mu sine A minus theta C, where theta C is the critical angle. Theta C is sine inverse 1 by mu. Okay, but you can also write it like this. See, I is equal to sine inverse mu sine A minus B can be written as sine A cos B minus cos A sine B, right? So I'll write sine A cos theta C minus cos A sine theta C. Okay, now sine theta C you know is 1 by mu. So cos theta C can be written as root over mu square minus 1 by mu, right? So you will write here I is equal to sine inverse mu sine A cos theta C. Sine A cos theta C can be written as root over mu square minus 1 by mu minus cos A sine theta C is 1 by mu. So from this, see, mu getting cancelled, take mu common, you will get I is equal to sine inverse root over mu square minus 1 sine A minus cos A. That is what is written there. So you can remember it like this also. For this particular angle of incidence, there is grazing emergence. For cylinder, if you remember, for cylindrical rod, this came out to be sine inverse root over mu square minus 1. But here it is coming sine inverse root over mu square minus 1 sine A minus cos A. Right? Okay. Now I will make one conclusion. This is very important conclusion that I will make. See, the conclusion that we will make here is, if A is greater than 2 theta C, if A is greater than 2 theta C, that is the angle between the two surfaces, or the angle of the prism or the refracting angle is greater than 2 theta C, in that case you will say that there is no emergence. That means whatever be the angle of incidence, no light will come out of the second surface. Then if A is less than theta C, that means the angle between the two prism is less than the critical angle, then you will say there is no TIR. Whatever be the angle of incidence, TIR cannot take place at this surface. That means there is only emergence. There is only emergence, whatever be the angle of incidence. Okay, there is only emergence. Right? Now, the next thing is, if A belongs to theta C to 2 theta C. See, I have derived this. I have not derived this. You have to do it yourself. So, try to derive this when A is less than theta C. Show that there cannot be TIR at the second surface. That is your homework. It is your job to do it by yourself. Now, the next conclusion is, if A belongs to theta C to 2 theta C. If A belongs to theta C to 2 theta C, in that case, if I is equal to sine inverse mu sine A minus theta C, I remember it like this, so I am writing it like this. If I is equal to sine inverse mu sine A minus theta C, then you will say grazing emergence. Grazing emergence. If I is greater than sine inverse mu sine A minus theta C, if I is greater than this, in that case what will happen? See, if I is greater than this, so because we have found out here I is equal to sine inverse mu sine A minus theta C, right? And for this particular angle that we have calculated, there is grazing emergence. Now if you increase I, R1 will increase. But if you increase R1, R2 will decrease, because R1 plus R2 is a constant. So if R1 increases, R2 decreases. So if you decrease this, then it becomes less than the critical angle. If it becomes less than the critical angle, that means there is emergence. So what you will write here is, if I is greater than this, then you will say that light emerge. And if I is less than sine inverse mu sine A minus theta C, in that case you will say TIR. So again I will repeat, if A is greater than 2 theta C, then there is no emergence, whatever be the angle of incidence. If A is less than theta C, then there is no TIR, whatever be the angle of incidence. But if A belongs to theta C to 2 theta C, in that case there are 3 cases. So that means this case that we have done, condition of grazing emergence, this is only if A belongs to theta C to 2 theta C. Okay. Now the next thing is condition of maximum deviation. Now this is experimental, and I'll tell you that delta is maximum, that is the angle of deviation is maximum when either I or A is 90 degree. That means it is either a grazing incidence or a grazing emergence. I or E, sorry. Either I or A is 90 degree, I or E is 90 degree. So it is either a grazing incidence or a grazing emergence. Listen carefully. If I is 90, that is grazing incidence, then E is sine inverse mu sine A minus theta C. And if if E is equal to 90 degree, then I is sine inverse mu sine A minus theta C. There is a principle of reciprocity here. If grazing emergence is there, then I will be this. But if grazing incidence is there, then E will be this. Okay. Again, provided A is belonging to theta C to 2 theta C, right? Because only if A is greater than theta C and less than 2 theta C, then the condition of emergence and no emergence comes, right? Because if A is greater than 2 theta C, in that case anyways light will not emerge, whatever be the angle of incidence. And if A is less than theta C, in that case anyways there will be no reflection, that is there will be no TIR, all the lights will emerge whatever be the angle of incidence. Only if A belongs to theta C to 2 theta C, in that case you will see these conditions, right? Okay. So now delta max will be equal to I plus E minus A, and I or E, either of them will be 90, and E will be, if I is 90, then E will be this sine inverse mu sine A minus theta C minus A. So this is the maximum deviation angle that you can get from a prism. But the next thing is, this is the most important thing, the condition of minimum deviation. See, deviation is minimum. You have to remember, again this is experimental. The deviation is minimum when I is equal to E. The deviation is minimum when I is equal to E. Listen carefully. If I is equal to E, then in that case, see, mu1 sin I is equal to, that is 1 into sin I is equal to mu sin R1, and mu sin R2 is equal to 1 into sin E. Now if I is equal to E, then R1 has to be equal to R2, right? From the two equations you will see, if I is equal to E implies R1 is equal to R2, and let it be R. But you also know that R1 plus R2 is A, that means 2R is equal to A, that is A is equal to R by 2, or R is equal to A by 2. So in the condition of minimum deviation, R is equal to A by 2. This is very important. So now I will apply Snell's law here. I will apply Snell's law in any of the one surface, because both surface is symmetrical in this case. So I will write 1 into sin I is equal to mu into sin R1, but R1 is again A by 2 because that is also equal to R2. So from this I will get sin I is equal to mu sin A by 2. This is very, very important relation in law, means the condition of minimum deviation. Then there is one more formula that will derive, that is the refractive index in terms of the angle of minimum deviation. Now delta mean will be how much, because delta mean is delta is I plus E minus A, but I is equal to E, so I'll write delta mean is 2I minus A, right? So I can be written as A plus delta mean by 2 from this. Just take A to the left hand side. Just put this value of I here, you will get the relation mu is equal to sine A plus delta min by 2 divided by sine A by 2. So you can remember this formula, but even if you don't remember this formula, the basics you have to remember. That is, for condition of minimum deviation, I is equal to E and R is equal to A by 2, and you can apply Snell's law on any of the surface. Now note that in the condition of minimum deviation, the light ray passes through the prism symmetrically, right? So if it is an equilateral or an isosceles prism, in that case the light inside the prism will be parallel to its base. So in case of minimum deviation, the light inside the prism will be parallel to the base. Okay. Now, variation of angle of deviation versus the angle of incidence. So this is a very important curve here, delta versus I graph. So delta versus I graph, I'll zoom it, delta versus I graph is like this. So you will see from here that for a given value of delta, there are two values of angle of incidence. Okay, for a given value of delta, there are two values of angle of incidence. Okay, so if this is taken as I, then this will be E. Similarly, if this is taken as I, this will be E. So I and E are interchangeable except the angle of minimum deviation. When there is minimum deviation, then I is equal to E, and it happens only once. Okay, but for a given any other deviation, you will have two values of angle of incidence. So that means, suppose I is 30 and E is 50, then when I will be 50, E will be 30, and both of them will give the same angle of deviation, because deviation is what? I plus E minus E A. So I and E, that is the sum of I and E, is same here as well as here, right? So that is why I and E are interchangeable, and for two values of I there is one deviation. Okay, so for one delta there are two values of the angle of incidence, and I and E are interchanged. We get the same value of delta because of the principle of reversibility of light. For application of result, means above result, the medium on both sides of the prism has to be same. This is obvious. We are taking the medium on both sides of the prism to be same. So based on the above graph, we can derive the following result, which says that I and E can be interchanged for a particular deviation. In other words, there are two angle of incidence for a given deviation except the minimum deviation, right? So if I is theta 1, R1 is theta 2, R2 is theta 4, E is theta 4, and delta is theta 5. Then when I and E are interchanged, then also delta will be theta 5. Okay, so there is only one, and only one angle of incidence for which the angle of deviation is minimum, and that is when I is equal to E. Okay, now let us do some problems based on prism. First question is, refracting angle, that is the angle of prism, is 60 degree and its refractive index is mu equal to 3 by 2. Then what is the angle of incidence to get minimum deviation? Also find the minimum deviation assuming surrounding medium to be air. So you know that in the condition of minimum deviation, R1 is equal to R2 is equal to R is equal to A by 2. So that will be equal to 30 degree because A is 60 degree, right? So I will write Snell's law in any of the surface. I will write mu1 sine, that is 1 into sine I, is equal to mu into sine 30. Okay, and mu is 3 by 2. So from this I will get 3 by 2 into sine 30 is half, that is 3 by 4. So you will get I is equal to sine inverse 3 by 4. Now once you get the value of I, then you will get the value of delta min as 2I minus A, and that is equal to 2 sine inverse 3 by 4 minus pi by 3. That is what you get. Now look at this question. In this question it is given to you that find the deviation caused by a prism having refractive angle 4 degree. That means it is a thin prism. 4 degree is a thin prism and the refractive index 3 by 2. You know that delta is equal to mu minus 1 into A, and from this you will write mu is 3 by 2 minus 1, and A is, if you write it in degree, you can write in degree also here because you are not taking the tan of this any angle. So delta is equal to 2 degree. So the deviation is approximately 2 degree. If you write it in radian, you will write 2 into pi by 180 radian, because 1 degree is pi by 180 radian. In this question it is given to you that for a prism the angle of prism is 60 degree and the refractive index is root over 7 by 3. Then find the minimum possible value of angle of incidence so that the light ray is refracted from the second surface. Okay, also find value of delta max. Listen carefully here. Basically this is nothing but the question of grazing emergence. What they are saying is find the maximum value of I for which there is grazing emergence. Okay, so you know that if I is greater than equal to, if I is greater than sine inverse mu sine A minus theta c, I have derived this. When I is greater than sine inverse mu sine A minus theta c, you will say that light transmits. Okay, so what they are asking is find the minimum value of I so that the light ray transmits, right, or refracts. So the minimum value is how much? The minimum value will be sine inverse mu sine A minus theta c. So now see, you know that sine theta c is 1 by mu, right? So sine theta c is equal to 1 by root 7 by 3, that is equal to root 3 by 7. So this is the value of sine theta c, right? And sine inverse mu sine A minus theta c will be how much? So I will write sine inverse mu sine A cos theta c. Now what is the value of cos theta c? If sine theta c is root 3 by 7, then cos theta c will be equal to root over 7 minus 3 divided by root 7, that is 2 by root 7. So sine A cos theta c, that is 2 by root 7, minus cos A sine theta c, that is root 3 by root 7, right? Okay, and the value of mu is root 7 by 3. So we will write here sine inverse mu is root 7 by 3 into sine A. Now A is 60 degrees, so sine A is root 3 by 2 into 2 by root 7 minus cos A. Cos 60 is half into root 3 by root 7. Clearly you can see that root 3 cancelled and root 7 also cancelled. So you will get this is equal to sine inverse 1 minus half, that is half, and that is equal to pi by 6 or the 30 degree. So that means if I is greater than 30 degree, then light will emerge. So the minimum possible value of I is 30 degree, right? If I is 30 degree here, then there is grazing emergence. If I is greater than 30 degree, then light will emerge. If I is less than 30 degree, light will reflect. Okay. Now in this question it is given that show that if A is greater than 2 theta c, this c is actually theta c, the critical angle, then TIR occurs at the second refracting surface for any value of I. This I have already derived. In fact, this 3 case I have already written in the lecture. If A is greater than 2 theta c, all rays are reflected back from the second surface. If A is less than theta c, no rays are reflected back from the second surface and all rays are transmitted. Okay. But if A belongs to theta c to 2 theta c, then some rays might be reflected, some rays might be transmitted depending on the angle of incidence. And we have also found out the angle of incidence, that is I is equal to sine inverse mu sine A minus theta c. If I is greater than this, transmission, and if I is less than this, reflection. Okay, so this I have already discussed. Now for this case we need to prove that R dash minus R is equal to A, and the deviation this time is I minus E plus A mod. Okay, we will not remember this formula because the prism is mostly not used in this way, right? We know that the prism is used mostly like this, okay, and not like this, right? So we will not remember this formula, but we need to prove for this situation that R dash minus R is equal to A. So here this is the normal, we can see that this is the normal, then this angle will be how much? This angle is 90, so this total angle is 90 plus R, and here this is the normal, so this angle is 90 minus R dash. So I will write 90 plus R plus 90 minus R dash plus A is equal to 180 degree. From here you can see that R minus R dash, or you can say R dash minus R is equal to A. So this is what we were asked to prove. Then comes the angle of deviation. To find the angle of deviation, let us see the incident and the emergent ray. I'll zoom it first. So see, the angle, this is the incident ray and this is the emergent ray. We need to find the angle between the incident ray and the emergent ray. So I will draw this and I will draw from here, and this is the intersection of the incident ray and the emergent ray, and this angle will be the angle of deviation delta, right? Okay, now if this angle is E, this angle is R dash, I can say that this angle is E minus R dash, and here this angle is 90 plus R and this angle is 90 minus I. So from this triangle I will write delta plus E minus R dash, delta plus E minus R dash plus 90 minus R plus 90 minus I has to be equal to 180 degree, because the sum of angles of a triangle is equal to 180 degree. From here you will see that this 90 90 this cancelled out, and R dash minus R is A. So from here R dash minus of R dash minus R will be A. Okay, so what I will write here, this was 90 plus R actually, so R dash minus R is A, so I will write delta plus E minus A. Why? Because I have taken R dash common, minus 1 common, then I will get minus 1 into R dash minus R, but R dash minus R is A. Okay, and from here there is I is equal to 0. So I have used this and this. Okay, so from here I am getting delta is equal to I minus E plus A magnitude. Okay, so we are getting I minus E plus A magnitude. This was what we needed to prove. Okay, so the deviation in this situation is I minus E plus A magnitude, and R dash minus R is equal to A. Okay, but you don't have to remember this. Why? Because prism is normally not used in this way. Now let us look at some more questions of prism. A beam of monochromatic light is incident at I is equal to 50 degree. So I is 50 degree on one face of an equilateral prism. So I am first doing the first question. Okay, and there is an equilateral prism, that means the angle of prism is 60 degree. The angle of emergence is given as 40 degree. Then what is the deviation? So deviation delta in this case will be equal to I plus E minus A, and that will be equal to 90 minus 60, and that is equal to 30 degree, right? So the deviation here is 30 degree. Now they have asked you the minimum deviation. Obviously this is not the minimum deviation condition, so deviation minimum will be less than 30 degree, because if the deviation in this case is 30 degree, the minimum deviation will be less than 30 degree. So you will say less than 30 degree, right? Now let us look at this question, right? So in this question it is given to you that a ray of light is incident at an angle 53 degree and emerges at an angle 37 degree. If the angle of incidence is made 50 degree, then which of the following is a possible value of the angle of emergence? Okay, so you know that this is the delta versus I graph. Now it is given to you in the question that the angle of incidence is 53 degree and the angle of emergence is 37 degree. So that means if this is 37, this is 53 degree, right? If this is 37, this is 53 degree. Okay, now what they have said is, now the incident angle is made 50 degree, so that means this has reduced. Now if this has reduced, then this should increase, because you know that for a given value of I and E there is one deviation, right? Okay, so that means if I has decreased from 53 to 50, then E will increase from 37. So definitely the answer will be greater than 37, but greater than 37 there are three options here, right? So now we have to check which option is correct. So first thing is, you know that I will be E will be greater than 37 degree, that is for sure. Now the second thing is, we know that the angle of deviation is I plus E minus A, right? and from here you can also see that the angle of deviation has decreased, right? So that means initial angle of deviation is 53 plus 37 minus a, and this has to be greater than 50 plus e minus a. So from this you will get one relation, that is 90 minus 50 has to be greater than 90 minus 50 has to be greater than e. That means e has to be less than 40. So we have one relation where we are saying that e is greater than 37, and the other relation where we are saying that e is less than 40. So if e is less than 40 and greater than 37, then only one option is correct here. So the answer will be 38 degree. Now in this question it is given that a prism refractive index is given to you as √3/2 and the refracting angle is 90 degree, that is the angle of prism is 90 degree. Then find the minimum deviation produced. So you know that the minimum deviation produced is given by this relation, mu is equal to sine a plus delta min by 2 divided by sine a by 2. Even if you don't know this relation, you know that in case of minimum deviation I is equal to E and R is equal to a by 2, use the Snell's law in any of the surface, you will get the value of mu. Okay, so you can also use the formula if you know. So mu is equal to sine a plus, that is 90 plus delta min by 2 divided by sine a by 2. Now sine a by 2 is sine 45, that is 1 by √2, and I can take it here. So this is equal to 1 by √2 multiplied by mu is √3/2. So from this you will get 90 plus delta min by 2 is equal to √3/2, and sine 60 is √3/2. So I'll write 60 degree. So from this you will get delta min is equal to 120 minus 90, that is 30 degree. So the minimum angle of deviation will come out to be 30 degree. Let us look at this question. In this question it is given that a certain prism is found to produce a minimum deviation of 38 degree. It produces a deviation of 44 degree when the angle of incidence is either 42 or 62 degree. Then what is the angle of incidence when it is undergoing minimum deviation? So from here it is given to you that angle of deviation is 44 degree when either I is 42 or 62. That means when I is 42, E is 62. So you will get delta is equal to I plus E minus A, that is 44 is equal to 62 plus 44, that is 104 minus A. From this you will get A is equal to 104 minus 44, that is 60 degree. Now once you get the value of A, it is given to you that the minimum deviation is 38 degree, right? So what you will write here, the minimum deviation is delta min is equal to 2i minus a. Now the minimum deviation is given as 38 is equal to 2i minus a is given as 60. So from this you will get 2i is equal to 60 minus or 60 plus 38, right? So 60 98, that means I will come out to be 49. Okay, so the I value will be 49 degrees. So at this angle of incidence, the angle of deviation is minimum, right? So this was the solution for this question, and this is the solution for this question. Okay, now let us look at this question. In this question it is given that a thin prism of angle 5 degree is placed at a distance of 10 centimeter from object. So we have a thin prism whose angle is given as 5 degree and it is placed at a distance 10 centimeter from the object. Then what is the distance of image from the object? So we have seen here that in a thin prism the distance between the image and the object is given by A delta, right? That is equal to A into mu minus 1 into capital A, where A is the object distance and that is given as 10 centimeter. Mu is given as 1.5 minus 1 will become 0.5 multiplied by A is, you have to write A in radian. So 5 degree means 5 into pi by 180. So from this we will get 10 5 50, 50 into 5 is 250, so divided by 10 is 25. So you will get 25 pi by 180. So you will get 5 into 5 25, and from here 5 3 15, and that is 36. So you will get 5 pi by 36 centimeter. Now let us look at this question. In this question it is given to you that light ray is incident on a prism at an angle of 60 degree and the refractive index is given as √2. The angle of incidence at which the emergent ray grazes the surface is. So they are asking you the value of I at which the there is grazing emergence. You know that the value of I for which there is grazing emergence is sine inverse mu sine A minus theta C, right? And sine theta C, you know sine theta C is 1 by mu is given as root 2, that means theta C is 45 degree. Okay, so from here I will write sine inverse mu, that is root 2, into sine A minus theta C. Sine A minus theta C, A is 60 degree, theta C is 45 degree, A minus theta C will be 15 degree, right? So I'll write sine 15 degree. Okay, so from this we will get sine inverse root 2 multiplied by sine 15 degree is how much? Root 3 minus 1 by 2 root 2, right? So from here you will say root 2 getting cancelled, and you will get sine inverse root 3 minus 1 by 2. So this is the angle of incidence for which there is grazing emergence, right? Then in this question it is given to you that a thin prism of angle 6 degree produces a deviation of 3 degree. Then what is the refractive index? This is very simple. You know that delta is equal to mu minus 1 into A for a thin prism. That's it. Delta is 3 degree, mu minus 1 into A is 6 degree, mu is equal to 1 plus half, that is 3 by 2. Okay. Now in this question it is given to you that the refractive index of the material of a prism is root 2. So mu is equal to root 2 and the prism angle is 30 degree. Then one of the refracting faces is polished. One of the refracting faces is polished. The incident beam of light will return back for the angle of incidence, which is okay. So see, this is the figure here. The angle is 30 degree and this is polished, right? Then the incident beam of light will return back for the angle of incidence, which is equal to, see, it will return back if the light ray strikes perpendicular to the polished surface, right? So that means if this angle is 30 degree, this angle is 30 degree, this is 90, then this angle is 60 degree, but the angle of refraction is this. If this is 60, this is 30. So we have to find the value of I. So I will write 1 into sine I. Okay, this diagram was missing from the question. I have drawn this diagram here. 1 into sine I is equal to mu into sine 30. So from this I will get sine I is equal to root 2 into half, and that is equal to 1 by root 2. From this we will get I is equal to 45 degree. In this question it is given that find the coordinates of the image of the point object O formed after reflection from the concave mirror as shown in the figure, assuming prism to be thin and small in size and the angle of prism is 2 degree. The refractive index of the prism material is 3 by 2. So first of all, you know that the image formation from a thin prism, the distance between the object and the image is given by D is equal to A delta, and that is equal to 5. A is 5, the object distance, and delta is mu minus 1 into A, that is 3 by 2 minus 1 multiplied by A. Now A you have to write it in radian. So I'll write 2 into pi by 180. So from this I will get 10 into 0.5, that means 5 pi by 180. Okay, so from this I will get, this is 336. So the distance between the object and the image is pi by 36, and I have told you that image is formed just above the object. So suppose this is the image formed. Now this image will act as object for the concave mirror, and for the concave mirror you can see that the object distance will be 25 centimeter, right? So I will write U is equal to, for the concave mirror, U is equal to minus 25. The focus is given to U as 30 centimeter. Okay, so it will be a minus 30 centimeter because it is a concave mirror, and I'll write V is equal to UF by U minus F, and this will be minus 25 into minus 30 divided by minus 25 minus minus 30, that is plus 30. So from this you will get 25 into 30 divided by 5, and this will come out to be 5.6, or you can say 5.5 and 35, 150 centimeter. So the value of V is 150 centimeter, and the magnification will be minus of V by U, that is 150 by minus 25, and from this you will get 25 into 5 is 125, that is 25 into 6. So the magnification will be 6, right? So that means it will be an erect and magnified image. So what they are asking you, the image position, right? So the image will be at a distance of 150 centimeter behind, right? The image will be at a distance of 150 centimeter behind, and it will be 6 times magnified. So that means it will be, if this length is pi by 36, then this length will be 6 pi by 36, that is pi by 6. So the coordinate of the image will be 25 plus 150, because this is the origin. So the coordinate of the image will be, the coordinate of the image will be 175 comma pi by 6, right? Okay. We will study dispersion in the next class. So with this, we have come to the end of today's lecture. In today's lecture, we have discussed prisms in details. In the next class, we will be starting with dispersion, and then we will start with refraction due to curved surface. Till then, stay tuned. Bye bye.